say, if it's not so obvious, you can do that for every monad.
Exactly. Or every monad transformer, that you can lift it through every monad transformer.
Yes.
So that's my question. Is it possible for any other monad transformer, and can you do it in some way generically?
I doubt it very much. So the reason that this is easy is that get and put simply construct values of type n something. They don't consume values of type n something. And as soon as you've got something like n plus that consumes those values, then you can no longer use the lift. Guess that sounds as though you would need to use some kind of run function on the underlying monad. Those run functions look different for each monad. So I think it would be very unlikely to be able to do it generically. For some monads, you perhaps can't do it at all. You might also look at this and say, oh, well, monad state is an easy case. Why don't we just write an instance here that says that, oh, God. Okay, why is it doing this? Because tell the machine my pen is too right on slides. So why don't I simply put any monad transformer here and add another constraint over here? Monad trans T. Wouldn't that be great? Then I could just write this instance once, and it would work. It would work for any monad transformer. Can't do it. And the reason you can't do it is, I think, a technicality about the way that the Haskell class system works. The type checker will look at this and will say, oh, look, T of n. I want to show that that's a monad state. I can simplify this constraint to this one. Sometimes that's the right thing to do. Often it's the right thing to do, but not always. However, if we write an instance where the right-hand side here looks completely generic, as though it works for any type T of n, then the type checker will always choose this instance. And its problem is that it doesn't backtrack from bad choices. So sadly, we have to actually write more specific instances so that they only match when they're actually good. Yes.
If that last thing is of interest to people, there's a paper from a few years ago by Mauro Jaskuliev called Modular Monad Transformers, where he formalizes how to do it in general and comes up with a mechanism that works pretty well.
Okay, but it's not in GHC.
Well, no, it works in GHC. So so in things like M plus are all isomorphic to something of the type that doesn't take a monadic argument, doesn't take an M of A as its first argument, because the end result is something of type M of A. And so if you just you can convert between them, and then you can lift those over any monad morphism. And so he comes up with a generic mechanism for lifting things. It has a port of the monad transformer library. The definitions of instances look really weird, though, like really weird, but it works.
Okay.